Hey guys, just doing another quick video. This one is on rational or fractional indices. So before we even get started on the maths, we need to determine what is a rational number. What does that mean? That's just any number that you can be sure it can be written in the form of a fraction. For example, a number p divided by the number q, where p and q are integers or whole numbers. What you'll notice is, as a result, if you express this fraction, p over q, as a decimal by doing the division, so chucking into your calculator p divided by q, the decimal will either terminate, so it stops, or it will be recurring, so it has a repeating combination. So a rational number is something that can be expressed as a fraction, and when you carry out the division of that fraction, you'll notice that the resulting decimal stops or it repeats. Let's do an example of that. So 10 over 5. 10 over 5 in the calculator, which I'll do off to the side here, is 2. How do we know that? Wrong color. How do we know that's rational? Because it stops. It terminated. What about 1 over 4? That's not going to be a whole number. However, 1 divided by 4 in the calculator is 0.25. It stopped. So once again, it terminated. Lastly, 1 over 7. Now, if you put this in your calculator, you go 1 divided by 7. It's going to look very long. It's going to look like it never stops, but it actually repeats. Because if I look at the results of my calculator, it says 0.142857142 9, and that's all it can handle. That's all it can display. But what actually is happening here is it's repeating 142857142. Why does it say 9? Because the number after the 8 is a 5. It's rounded that 8 up to 9. So this is actually 0.1428557 recurring. So that is also a rational number because it recurs and it can be expressed as one integer over another as a fraction. Now, what does this have to do with indices, the topic that we're doing? Well, the index laws do not just apply for whole number indices that we've done before. They apply for rational indices as well, which are indices that are fractions. Fractional indices actually represent something called roots. You may have experienced roots before when you were dealing with Pythagoras, but they're numbers written with a square root sign there. These are numbers that when you multiply them by themselves, they get a number that you're interested in. So for example, the square root of 9 is 3. So my number of interest is 9. The root is 3. So to show you how some index laws involve rational indices, we've got a to the power of a half. That is equivalent to the square root of a. So just a warning to you, if you ever see the root symbol here and there is no number, we can assume that that number is actually 2. That's a given. That's something that we agree on in mathematics. So if we see the root sign, we assume that it's square root if it doesn't have a number there. So for example, e.g., 16 to the power of a half is equivalent to the square root of 16. What is a number that I times by itself to get 16? Well, that is 4. Okay? Now something slightly different. Base number a to the power of 1/3. What you'll notice here is that it's actually the cube root of a. So notice, just keep in mind, because we're moving towards something here, the denominator of that root became the level of root. The denominator of that rational index became the level of root that we're talking about here. So for example, 8 to the power of negative 1/3. So I've chucked in a negative index here, but based on previous exercises and previous videos, you should know how to deal with negative indices. So as soon as you see a negative index, it's talking about reciprocals. So 8 is actually 8 over 1 as a fraction to the negative 1/3. So all I did is rewrite. I haven't done anything yet. The negative index flips it. So it's 1 over 8 now to the power of a third. Then according to the index laws, if you've got a fraction here raised to a power, that power applies to the top and the bottom. So now it's going to be cube root of 1 over cube root of 8. The cube root of 1 is just going to be 1. However, the cube root of 8, the number that I times by itself 3 times to get 8, is 2. So 8 to the negative 1/3 is actually 1/2. Okay? Now we'll go on. So in general, what you're going to see is that any base number to the power of a rational index, where the numerator is m, the denominator is n, that denominator is actually the level of root. Then you have the base number to the power of the numerator of that rational index. This is also equivalent to that level of root with the base number all to the power of that numerator. They're the same thing. So if we had an example here, 7 to the power of 2/3 is equivalent to, the denominator is 3, so we're talking about cube root, over the base number is 7, and that base number 7 is being squared because that's the numerator. That is also equivalent to cube root of 7 all squared. They're exactly the same thing. So in the fractional index, the denominator is what? The denominator is the level of root. And the numerator is the power it is raised to. And the power the base number is raised to. Or the power that the whole root is raised to. Both the same thing. So let's do another example here. Write 16 over root 2 as a power of 2. There are no powers of 2 here at all, so we need to do some working out. So 16. I know that 16 is 2 to the power of 4, because 2 times 2 is 4, times 2 is 8. That's 3 multiplications, and then times 2 is 16. So 2 to the power of 4 over root 2. Now 2 to the power of 4 over, we just learned in this video that the square root is actually a power of 1/2. Now we use our index laws. We have the same base number of 2. You're dividing, so you take away the indices. So it's 2 to the power of 4, take a half, which is equal to 2 to the power of 3.5, which is the answer. But just keep in mind, it's probably easy to do working out when you have an improper fraction. So 3.5 is the same as 2 times 3 plus 1, 7 halves. 2 to the power of 7 over 2. These answers are both acceptable because it's just asking for 16 over root 2 as a power of 2, 2 to the power of 3.5, 2 to the power of 7 halves is fine. Alright, so that is that video on rational indices. Hopefully that helps you out, and I'll see you on the next video.